Why did my C++ program create a crash dump, and how do I fix it? Imagine your C++ program suddenly stops working and leaves behind a crash dump. It might seem like a mystery, but there's a clear reason behind it. When your program encounters a serious error, the operating system creates a crash dump. This dump captures the program's memory and state at the moment of failure. It helps developers figure out what went wrong. Most crashes happen because of illegal operations. For example, a segmentation fault occurs when your program tries to access memory it shouldn't. This can happen if you access an array outside its bounds or dereference a null pointer. Writing to read-only memory, like string literal, can also cause crashes. If you have uninitialized or corrupted pointers, your program might try to use invalid memory, leading to a crash. Buffer overflows happen when you write more data than a buffer can hold, overwriting nearby memory. Sometimes, executing invalid CPU instructions causes crashes too. A common cause is stack overflow, which happens if a recursive function calls itself endlessly without a base case. Because C++ does not automatically check array bounds or memory safety, these issues often lead to crashes. When your program crashes, it generates a dump to help you analyze the problem later. To fix these crashes, start by running your program inside a debugger like GDB or LLDB. These tools pause execution exactly where the crash happens. They show you the line of code and the call stack, which is the sequence of function calls leading to the crash. This makes it easier to identify the faulty code. Make sure your operating system is set to generate core dumps. These dumps are snapshots of your program's memory and can be loaded into a debugger later. Use tools like AddressSanitizer or Valgrind to detect memory errors, leaks, and invalid memory accesses. These tools can catch issues before they cause crashes. Check your pointers carefully. Always initialize pointers before use and avoid writing to string literal or read-only memory. Review your array and buffer sizes to prevent overruns. If you have recursive functions, ensure they have proper base cases to prevent stack overflow. Add assertions and error checks to catch invalid conditions early. Modern C++ offers safer alternatives. Use std, vector instead of raw arrays, and smart pointers like std, unique PTR or std, shared PTR to manage memory automatically. These practices reduce the chance of bugs that lead to crashes. If your program creates crash dumps, load them into a debugger. Inspect the crash context, examine the call stack, and review variable values at the time of failure. This process helps you pinpoint the root cause. By systematically applying debugging techniques and memory safety checks, you can identify why your C++ program crashed and fix the bugs. This approach makes your code more stable and reliable, helping you become better at fixing programming bugs efficiently.